Hi everybody, this is Mr. Zarzak here. I'm going to take you through a couple activities I need you to complete. Alright, so first up is go to the Conceptual Physics group and go into the Unit 7 Waves folder. Alright, and then under Student Note Templates, the black folder, we're going to pick the third one down. It's called Notes, Waves, and Sound Equations. So click on that, let it load up. Okay, and we're going to import this into Notability. We're going to use this as a summary sheet that we're going to build throughout the unit. Put it in my Waves folder there. So we won't fill this out completely today. Navigate to my folder. Let's see here. Here we go. Alright. So we're going to fill in the blue box, the black box, and then the red box down at the bottom. The black beat frequency and the green temperature equation will come a little bit later in the unit. Alright, so scrolling into this. This is a summary. I'm pulling some information from your Waves notes. Okay, so the two things that we have here are, if you remember, is T is the period for the wave. Okay, and it's measured in seconds. Alright, and then we've got F, which is frequency, which is measured in hertz, which we abbreviate Hz. These two things are inverses of one another. So period is equal to 1 over F, and F is equal to 1 over T for period. So if we know one, we know the other. Now, the new thing that we're going to work through today is the wave speed equation. So the speed of a wave, v, is equal to the product of the wavelength, which is that symbol lambda, times f, which is the frequency. And because period and frequency are inverses of one another, I can also write this equation as v is equal to wavelength over period. And you can think of this as wavelength is the distance for a wave and period is the time for a wave. So really this is just another version of speed is equal to distance over time. Alright, speaking to that, if I just scroll over to the right here, it says, now don't you forget, speed is distance over time, and speed times time is equal to distance. All right. Now if I scroll down to the bottom here for standing waves, okay, if you remember, standing waves are defined in terms of nodes and antinodes. So this is really information that we pulled from the Slinky lab. So over here I'm going to write the word antinodes. Alright, and antinodes, or the number of antinodes, is equal to the harmonic number. So the first harmonic has one antinode, the second harmonic has two antinodes, and so on and so forth. And one way that we can distinguish these is just with a little slash. You'll see what I mean here in just a second. Now over here on the other side, I have nodes. So nodes is just equal to the harmonic number n plus 1. So think when n is equal to 1, the first harmonic, there's two nodes. When n is equal to 2, there's three nodes, and so on and so forth. Okay, so for the example that I gave you here, this standing wave is when the harmonic is equal to 2. These little dash lines are to signify that the wave is in motion, but it's these pieces here that are oscillating up and down here and here. Those are your antinodes. That's why we use that little slash to signify the antinodes, to show movement, that it's going up and down. And then just in blue here, sorry, I should have written that before, nodes are going to make little blue dots like that. For the second harmonic, there's 1, 2, 3 nodes. Okay. Also, if you remember from the lab, in question number 13, we defined the wavelength equation in terms of the length, and that was wavelength is equal to 2 over n, where n is the harmonic number, times the length of whatever is producing the wave. So here I've got this green line to represent the length over which the wave is being produced. And so I can describe that as wavelength as 2 over n times L. It allows me to calculate based upon length and wavelength. I can also write this equation as length equals n divided by 2 times lambda. So I've just taken and rearranged it. Okay, so these are all good things to have on your note card for the upcoming quiz. All right, now, once this is done, I'm going to jump back over to Schoology. Okay, and today we're going to be working practice file 7-2, so we're going a little out of order here. So go to 7-2. Now, when you try to open this up in Schoology, it's going to tell you that it's unable to view the file. This is because this is a Notability file. There are some things in here, some features that you can only access in Notability. So don't worry about that. Just click on the little open button over here in the upper right-hand corner, and then hit Notability. Okay, go ahead and create new note and import it in. Okay, so I'm going to jump over to Notability here. All right, and I'm going to navigate down to practice file 7-2. Okay, so why is it that it wouldn't open in Schoology, but it does here? Because there's some objects in here that you can manipulate. So if I press this T button up here, this text button, these rulers down here are actually objects that you can drag and move around. Depending upon which version of Notability you have, you can also take and rotate these tools so that you can actually make measurements within the file. If you haven't updated your Notability, that's all right. We gave you one vertical ruler and one horizontal ruler to work through. Also, if you scroll down to the very end of this, okay, you'll see that there's an animation down at the bottom, and just by tapping on the screen and holding it, you can actually freeze it to look at it at different points. All right, most of this is just review, and it's also designed to teach you how to use that new velocity is equal to wavelength times frequency equation. So I'm just going to give you some hints wherever you see speed. So I see down here, assume the speed of sound is 340 meters per second. So question 8 is one place where you're going to use this. V is equal to wavelength times frequency. All right. There's a couple other spots in here where this is used to. You use this in question number 9. You're going to use this in question number 11. Okay, and then you're going to use this down here for questions number 13 and number 15 as well. When you get to questions 17, 18, and 19, we haven't covered Doppler effects, so if you don't know how to do those just yet, it's all right. But at least you can try them out on the Socrative. So for now, for the rest of the class, your job is to log into Socrative to our class like normal, and then to complete practice file 7-2. Anything you don't finish is homework. See you tomorrow.